Hello, this is Chapter 13 from our OER textbook, Clinical Calculations, Math 1120 through Pikes Peak State College. JoAnne Myers here. All right, the key to solving any equation is to remember that you can do pretty much anything to both sides of an equation. You can add, subtract, multiply. You can divide by both sides of an equation, so long as you don't divide by a zero. That's the tool, or the trick, as some like to call it, that allows you to rearrange the given equation, rewrite it so it has the same value, but it's easier to see the answer. Writing your answer to number 1 means find the solution, find the value for x that when it's multiplied by 7 and you add 8, you end up with a negative 13. If you don't know that right off, then you choose to do whatever you want to both sides of equations. And so basically what you're doing is you're going to isolate the x. So add, subtract, multiply, and divide, whatever you want to get that variable all by itself. First thing I'm going to do to number 1 is subtract 8 from both sides. Minus 8 is the same thing as minus 8, so I'm subtracting from both sides. The left side, when I simplify the expression on the left, 7x plus 8 minus 8, leaves me with just 7x. Minus 13 minus 8 is a minus 21. I lost $13, I lost 8 more, so the bottom line is I'm down 31. Now what's blocking my goal to have x isolated is that multiplication by 7. So I choose to divide both sides by 7, and my final answer, x is negative 21 divided by positive 7. Negative divided by positive is negative, and 7 divided by 21 is 3. So my original equation here, 7x plus 8 equals negative 13, whenever this equation here, x equals negative 3, is true. Well, the only solution to this equation where x equals negative 3 is when x is in fact negative 3. So the only solution to the original equation is when x equals 3. So again, when you're solving an equation, your goal and your assignment is to tell me all of the values of the variable that will make the equation true. How do we do this? We isolate the variable. We rearrange the given equation with a series of equivalent equations like 7x equals negative 21 or x equals negative 3. You keep rearranging the original equation until it's something incredibly obvious. Do number 5. I want to isolate the variable y. Well, I now have a y on each side of the equation. Always make sure you identify where your equal sign is and then do whatever you want to both sides of the equation to reach your goal. Your ultimate goal is to isolate that variable, in this case, y. The left side, 5y minus 5y minus 9 is the same thing as minus 9. 8y minus 5y, if I have 8 yellow jackets and I subtract 5 yellow jackets, 8 minus 5 is 3. I will be left with 3 y's. Now, what do I do to both sides? Well, my goal is isolate the y. What's blocking my goal is that multiplication. So I choose to divide. I divide by the coefficient. I divide by the number in front of my variable. So I now have negative 3 is the same thing as y. A goofy coincidence that they come out with the same answer. Number 7. I have 12x is the same thing as the opposite of x plus 26. What number multiplied by 12 will have the same value as the opposite of that number plus 26? I don't know, but what I do know is I can do the same thing to both sides of the equation. keep my equal signs lined up. Minus x plus x is 0. That's why I chose to add x to both sides. The right side becomes 26. The left side is 12x plus 1x. So I have 13. At this point, you probably can tell that x will be 2. If you can't tell, then keep working until that x is isolated. What's blocking your goal is 13. So choose to divide both sides by the same thing. The left side, I now have x all on one side and isolated. I have the numbers all the way on the right side, simplified. So whenever x is 2, my equation in the green box will be true. Well, that means if I put a 2 up in the original equation will also be true. So here's a quick check. Our mission was to find some number that when it's multiplied by 12 is the same thing as the opposite of that number plus 26. Our algebraic skills showed us that when x is 2, this equation should be true. So let's check. 12 times 2 is 24. The right side, negative 2 plus 26 is in fact 24. So our original equation is true whenever x equals 2. So the solution to our original equation, 12x equals the opposite of x plus 26, is the value x equal 2. Again, yes, you can add or subtract anything you want to both sides of the equation. Make sure the equal sign stays lined up and do whatever you want. Looking at number 10, I have an n here and an n here. My goal is to isolate the variable n so I can do whatever I want to both sides of the equation. Write the equal sign down so you don't make a silly mistake. Tell yourself and anyone reading your paper what you're doing to both sides. 8n minus 2n is 6n. I still have a minus 4. The right side becomes 0 plus 6. You don't have to write the 0, but you can. Now I'm going to get rid of this negative 4 by choosing to do the opposite, but I have to do the same to both sides. I know some teachers like to teach students, oh, it changes the sign when you cross the equal sign. Well, that's just make up math. It's not really algebra. It's a pattern that works if you remember the right conditions under which you're allowed to use it. I think it's easier to remember one fact that you can do pretty much whatever you want so long as you do the same thing to both sides of the equation. And your goal is to isolate the variable. So you pick numbers to add, subtract, multiply, or divide that will help you reach that goal. And you do the same thing to both sides of the equation. N equals 5/3 is what I would put. If I had to change that to the mixed number, it slides over to the right. 5 divided by 3. Yes, if it's a calculator deal, you could put it into a calculator. If you're not allowed a calculator, your mixed number will be 1 2/3. The reason is this 5/3 comes over. This is 5 divided by 3. The remainder 2 is the numerator, and your denominator remains the same. Jump down here. Find your equal sign. If you add, subtract, multiply, or divide a magic number that you pull out of the air, you have to do it to both sides of the equation. What I'm going to do first is just rearrange the work. So I'm looking just at the left side. I'm looking at this set of parentheses. I have the distributive property that says I can multiply this 4/10 by each term inside the parentheses. So I have 4/10 x minus 4/10 times 1, which is just 4/10. I still have that minus 2 And there's my equal sign. Now I'll work on the right side and simplify all of this. Again, I have parentheses. The distributive property tells me I can multiply what is outside of the parentheses by each term. So 5 times the term 2x, 5 times a positive 3, positive times positive is positive, and 5 times 3 is 15. Then I'm going to copy the rest of this side of the equation. And then honestly, I'm going to grab a calculator. So again, my goal is to get all of the values with x on one side of the equation and all of the numbers on the other. The first thing I want to do is simplify this right side. 10x plus 1x is 11x. 15 minus 4 and 15/100 is 1085. I gained more than I lost. Left side looking over here, I have a term with an x, I have a number and another number. So I have 4/10 that's negative. Notice your calculator will have a plus minus that lets you just change the symbol. So now it's a negative 4/10, and then I subtract 2 from that. Now I want to get my x and y values on the same side of the equation. I'm going to add 2.4 to both sides. I'll use a different color. I'm adding 2.4 to 1085, 1325. Again, you'll notice I'm keeping my equal signs lined up. I'm adding everything on the right side, adding everything on the left side. I still have x's on both sides of the equation. I'm going to choose to subtract 11x from both sides. So now I have 0.4 minus 11, 10.6 negative. Keep your equal signs lined up, left side, because it's 10.6x, right side is still 1325. My goal is still to isolate the x. What's blocking that goal is multiplying by a negative 10.6. So I choose to divide by negative 10.6. Final answer. 1.25. And my answer will be negative, because negative divided by positive and positive divided by negative give you negative. Again, I have a positive divided by a negative, so my answer will be negative. Hopefully you will have that memorized. If not, your calculator can help you. 1325 divided by 10.6 that's a negative, make sure you use this plus minus button here that changes the sign and is not subtracting. And then you'll find out it's a negative 125. If you have questions or comments or need to see more examples, let me know. Shoot me an email.